All right, so the last major trend we want to talk about in the periodic table is electron arrangement and how this electron configuration played into how we organize the table now. Knowing this, just knowing electron configuration and having a periodic table, you should be able to figure out where an element falls on the table. So, quick review, what are our valence electrons? Hopefully you're remembering that they are, the outermost electrons or the ones involved in bonding, something like that. All right, so an element very well may have more electrons than their valence electrons, and those are just going to be more towards the center. For example, neon has 10 electrons total, but only 8 of them are in their valence electron shell, or the outermost shell. So, and that lends us to talk about this octet rule. So there is something about having 8 valence electrons that makes atoms really stable. And as we get into bonding and things like that, we're going to use this octet rule a lot. Something unique to the noble gases, which are the very last column on the periodic table, is they all have a full octet, all right? Or in their electron configuration, they have their final S and P shells are full, all right? So you can see they all end in 3s2, S2 and P6. The number out front changes because they are in different periods, but they all have a full final S shell and a full final P shell. Similarly, other groups have their own unique valence electron pattern. All right, so like for example, group 1A, or the very first column in the periodic table, they all end with 1 electron in their final S shell. All right? Or group 2A, that's these guys here, or group 2, the second column, they all have 2 electrons in their final S shell. All right? And another example on the other side of the periodic table, these are let's see, you can think of this as group 17, group 7A, your halogens. All right, they all have 2 electrons in their S shell and then 5 electrons in their P shell. So 1 shy of being full of their octet. So using that sort of pattern, you can figure out where an electron falls on the periodic table based on these electron configuration blocks. All right? So the first 2 columns are the S block. All right, the last 6 columns are the P block. The transition metals in the center are part of the D block. And then the F block only exists for the inner transition metals. All right, number-wise, all right, for the most part, the period corresponds to the number, the row or the energy level of the block, with the exception of D's and F's. And that's just because there's not a D or an F block for every single row. All right, so you may want to jot this down as well, because you'll see this picture on the left in your coursework quite a bit, but this one on the right is something that I added. All right, so that way you can kind of remember the numbering of your S, P's, D's, and F blocks, just so that, when you see an electron configuration, you know where things are supposed to fall. Say, for example, like this. So, just knowing this electron configuration, if you zone in on the end of the electron configuration, all right, and what you'll know, or really what you're focusing in on, is the valence electron configuration. All right, so focus on the highest number all right, to the end of the configuration. That is the valence electron configuration. This is something you'll probably want to write down. All right, so for example, in this first one, the highest number is 4, so the electron configuration for the valence electrons of this atom is 4s, which means that the electron is going to fall somewhere in the s block. Oops. All right, specifically, it is going to fall in the 4th level of the s block, and it's going to have 2 electrons, so it's going to fall in the 2nd column. All right, which means that this is the electron configuration for calcium. All right, another way you can think of it is, this next one. Identify your valence electron pattern. All right, so again, our highest number is 2, so highlighting our valence electron configuration. This means that we are going to fall in the highest letter, or the farthest out letter is P, so we're going to fall somewhere in the P block. So we're going to be somewhere over here. All right, we are going to be in level 2 because it's 2s and 2p. All right, and we're going to have 3 p electrons. So 1, 2, 3. That means this is the configuration for nitrogen. All right, next one's a little tricky because it involves the block, which is where numbers kind of get a little screwy. And this is why when you are trying to figure out what your valence electron configuration is, you zone in on the highest number, and then everything past that is your electron configuration. All right, so what this means is that our atom falls somewhere in the D block because that's the last letter. All right, so it's going to be somewhere in here, but it's going to be in the 4th row because that's the highest number in the electron configuration. All right, so it's going to be, and then finally, since we've got just 1 in the D block, that means we are right there, SC. All right, you won't see transition metal ones too much. I just wanted to expose you to one of them. But see if you can figure out which element has this electron configuration. All right, so big, long configuration, but if you remember, all you need to really focus in on is that valence electron configuration. So find that highest number. Then go to that row in the periodic table, that block based on the letter, and then count over that many electrons in the number. So if you did this correctly, you would find that you are in period 5, because the highest number is 5. The last letter is S, so you're going to be somewhere in your S block. And you're going to have 2 electrons, so this is strontium. All right, one more practice related to this. In what block would you find an element with the electron configuration of 1s, 2, 2s2, 2p6? So this one's a little bit simpler. You don't even have to narrow it down to the electron. Just what block would you find it in? All right, so you, again, highlight the highest number forward, so it's the first 2, and then the last letter is your block. So this would be in the P block.